Hello all and welcome back to the second engine build on this channel. As you've seen in previous videos, we have been working on my 1969 CT70. It's undergoing a full restoration and build, and now's the time to tackle the engine. So as you can see in front of me, and by them close-ups, we've got two freshly vapor blasted engine cases along with a load of other bits, and you may also see we've got two boxes from Kitaco, so some Japanese parts for this build. We've got an 88cc kit, including cylinder head, piston, the works, and we've also got a full manual clutch conversion kit. So it's going to be a really nice engine build, not cheap by any means, but that cool sort of OEM plus build. Enough talking from me though, let's get straight into the action and I will voice over the rest of this video. Enjoy. Hello all and welcome back to engine number 2 being built on this channel. Obviously it's very similar to the 50cc, but this is going to be a bit more peppy. We're going for more power and more performance, so it's usable on the road. But we're starting off with the crankcases. We've got these nicely vapor blasted, and we're going to start by removing the studs so we can get access to this oil hole. As we're going for more power, we're also going to be fitting a bigger oil pump, and there's no point having a bigger oil pump if you can't pass that oil around the engine. So there's a small hole that passes oil from the crankcase and up to the cylinder head, so we're going to go ahead and drill this out to 2mm. Doesn't sound like a lot, but it's enough to allow that pump to really flow that oil around the engine. So miraculously, these studs actually came in and out of the engine very well. I was fully expecting to wrestle these things and have a real nightmare, but they were smooth, so it was a good job to start with. Off camera, I've blasted these cases off with some compressed air, and here I am just giving them another clean. Obviously with that drilling, I want to make sure there is no swarf whatsoever in this engine. Next up, we're going to lightly heat these cases just to make the bearing surrounds swell up, and then we're going to pull our bearings out the freezer and drop these into place. And on one side of the case it went in beautifully, but as you can see here, this one fought me a bit more. So with a nice perfectly fitting socket, we hammer the bearing home and then just check it spins all nicely. They're completely dry at the moment, so obviously when covered in oil they will be nice and smooth. With those done, we pop them outside and let them cool off before we move on to the next part of the build. Outside in the sun, looking epic. Considering it's from 1969, it is nice and clean. So guys, as you saw in those last clips, we got the bearings and the oil pump hole drilled out, which is really good. It's a few weeks later now and I'm back in the shed. I've got all the parts ready. I've set up a cleaning station here, so all parts from the original engine will come up here. They'll get cleaned off and checked and inspected. I've got my nice manual ready to go, and then we'll be building the engine over here with the two halves ready to go. Like I said, the bearings are in, they're all vapor blasted and they are ready to be assembled. So I'm going to set a camera up and get to work. Been looking forward to this for a long time, so it'll be nice to get this thing built. So let's get straight into that and start assembling. Right, now it is time for the fun bit of getting this engine together. As mentioned there, I've ran you briefly through my process. Because a lot of these engine parts came out and maybe didn't get the biggest clean, we're going to make it a priority to give them a really good clean now and inspect them before they go back in the cases. That way I have peace of mind knowing that everything is good on this engine. Obviously when you strip these apart, it's normally a while before you rebuild them. Well, in my case it is, so it's good to do that double check. But kickstart shaft went in first, and now we've got the gearbox on the table. I've kept it together as one unit as such, just as it makes it easier to assemble and easier to check. But you can see we locate the input shaft, the gear selector, and we'll set them into their bushings, and then with some little play we get it nicely in place. Quick spin just to make sure we haven't severely damaged anything or not located it right, and we're good to go. Now with these engines, or any engine, when you first look at it, it may seem complicated or a bit daunting, but get your manual beside you, look at pictures, and it will go together nice and easily. Crank goes in now, following the gearbox, and we give everything a quick spin just to check it's free and moving nicely. Because when I put the other case half on, I'll be doing the same, and I want to make sure that it is still nice and free. Part alert guys, because this is a centre gasket, we've gone for a Honda OEM to make sure there is no chance of this puppy leaking. I do not want a mid-engine leak after building this engine. So guys, this is complete preference, but I like to do that. I didn't do it in my last one, and in hindsight I should have. So with your centre gasket, which I've just unpacked, obviously goes between your two case halves, I'm going to add a small bit of sealant on this case. So I'm going to dab that around, really thin layer, and it's just a nice bit of reassurance that you're not going to get a centre crankcase leak, because out of all places to leak, that's the last one you want, because you've got to split the cases again. So each to their own, but I'm going to run with this. As mentioned, we're going to get this sealant onto the case. We're going to apply it to both case halves, just applying a very thin layer. As far as I'm aware, this stuff will always stay wet and never cure, but it's great and just fills those small imperfections you may have. In theory, with a new gasket and some flat cases, you shouldn't have this issue, but I would rather be safe than sorry. So with those two bits on, we can go ahead and slide this case together. And there's always a little bit of resistance, but I have to say, this one went together a dream. I was very surprised that it literally dropped down and mated perfectly on the other surface. Not complaining though, because that is exactly what we want. And as mentioned, another sanity check. Get those shafts, give them a quick move, and see if you can feel any resistance. They should all spin very smoothly. Next up is the bolts, and I have time-lapsed this as it is very repetitive, but you know how it goes. Put the right bolt in the right hole. If it's too long, take it out and try again. But we work our way around, getting these all in and situated, and then tightening up in a star pattern, just taking our time to spread the load across the case evenly. Most important thing, use the right screwdriver. I've been there and used the wrong one, and right JIS head, and it is a game changer. With the two cases together, next up is to put it on my cool new engine stand, which I will discuss with you now. Now guys, I have to say, I think that is really cool. Never built a stand before. Obviously, I mentioned I whipped up this little frame just to hold the engine, and it makes it a load better. Nice working height, it's nice and solid, it's not going anywhere. Now the two cases are together, you're set really, and you can build the rest of the engine. So, makes a big difference. I know you can buy them off the shelf, but whipped that one up myself, scrap metal, worked a treat. So, let's keep going. So, next bolt to go in is the bolt for the rear of the shift barrel, and out comes my trusty 1/4 inch Wearer torque wrench. This is a lovely little bit of kit, and for these smaller engines and smaller bolts, it is perfect. So, get that set and torque this to spec. From now on, I'll be talking to spec as necessary, and following that, I get the main seal in for the output shaft or your sprocket shaft. Prior to putting these seals in, I'm making sure they've got a good coating of grease and making sure to use the right impact or socket to push them home, just spreading the load evenly across the part. With those seals in, I move on to the left hand side of the engine, and one of the first things I want to get in is this cam chain tensioner, purely because it's nice and easy to get in now with everything else out the way. So it's a much larger bolt, this one, so we wind that home and tighten it up with the socket, and then I proceed to go and drop that bottom spring in, which gives it tension. As you'll see throughout the build, we are putting lube on all of the parts. Just a light film makes it go together easier, and as it won't run for a while, it's good practice. But there you can see the spring going into the bottom of the engine, and that is what gives tension, as you can see here, for the cam chain. So let's have an update at where we are in the engine build, because we're making some good progress. So coming round, as I mentioned, the engine's on the stand. we've got the tensioner in. There you go. I've just done that loose for now because I'll probably adjust it. We have got seals in for the output shaft and for the gear shift lever there, and now we're going to come around to the other side and start on the whole gear shift mechanism. That also includes the oil pump, which sits down here. Because we are going for power, because that's what we want, we're also going to be installing a bigger oil pump. So we've got the Kitaco high flow because yep, it flows some serious oil, and that's also going to be going on to support our bigger piston and barrel and head, which I will show you when we put that on. Straight into the other side of the engine, you can see very different, but we're going to start with this kickstart spring and get that located in place. It is a beefy old spring, so take care fitting that. It's easy to slip and stab yourself with a screwdriver. Following that, you get your circlip. I opted for a new circlip because these get pretty knackered, especially when you're taking them off. Now it's time to look at our oil pump. This is one of the first upgrade parts going onto the engine. A very simple thing, and you'll laugh because look at the size of the oil pump. This is an upgraded one, but they are just absolutely tiny. But nonetheless, a cool bit of kit, and hopefully something that will give us some reliability for this extra power. So your shaft goes through the centre and you wind on your sprocket, and then your gasket goes on, and next up your lovely oil pump. I have made sure to prime this oil pump, and that just makes getting oil through this engine way easier when you first come to start it. With that oil pump all nipped up, we go to the back of the engine and start looking at the shifter mechanism. And I can tell you guys, I've already made a mistake because I've got a brand new manual clutch kit on the bench, and I've just fitted the original shift assembly. So I wasn't thinking at this point, and yeah, it slipped my mind. So I got ahead of myself, and then as you'll see, I come to unbox the new stuff, and yeah, end up being a bit premature with it. Despite fitting the wrong shifting, we'll figure that out in the future. Right now I'm back to the other side and we're going to get the cam chain on. So cam chain is just good to get in place early on, just to make sure you've got no issues, and it also makes feeding it around that oil pump drive much easier. And you can just check that the teeth aren't worn, it's going to move nicely, and you're going to have no issues. And with the cam chain in, it means that we can oil up the surface and start working on fitting this new electronic ignition. One thing to remember is to always put a fresh O-ring around this sealing edge, because so many times I've done it and I've had leaks, and it is a pain in the arse when that leaks all through here, into your stator, outside of your case. So it's so worth putting a good seal on the outside of that. With that new seal ready to go, we lever off the old one, apply a thin layer of oil, and then get the new one in place. Just being careful not to nick it or rip it at all. And then when you come to fit this, you will find that it is a very tight fit. That is good because it means the O-ring is fresh and you are compressing it. If it drops in really easily, more chance of a leak. But you can see this is a aftermarket electronic ignition for the 6-volt engine, which should hopefully make a massive difference, because yeah, electronic ignition is way superior to the points and condensers. As mentioned, this isn't a standard Honda build like the last one. We're going to add a bit of spice to this bike, so it's a bit more usable on the road. To do that, we have gone and bought some aftermarket parts from Kitaco. Now, I know I covered this briefly at the start of the video, but I thought I'd give you a little rundown of what you get in these boxes in case you were thinking about putting one of these kits on your bike. Now, this is definitely a high-end kit. It's a nice one, but I thought I want to use this. I want it to last a long time, so let's go nice. But overall, it's an 88cc kit. So in that, obviously, you get the bigger piston, you get your wrist pin or your gudgeon pin, you get a cylinder head, a barrel, and this comes standard silver, but as shown in the video, I have painted it so it matches the standard colours. And if you feel the weight of this, it is super light compared to the standard cast one. So got to be a good upgrade, nice and modern. And one of the reasons why I really wanted this kit was for the cylinder head. So anyone familiar with these bikes, it's 1969. These cylinder heads get knackered. The valves are absolutely tiny, so getting any work done is a nightmare. I spoke to machine shops before and they don't really touch them. So a great upgrade is this. So Kitaco offer a new cylinder head. It is a Kitaco casting with bigger valves. So you get a bigger inlet, a bigger exhaust. It comes fully built with springs all together. All you've got to do is put a bigger camshaft in it, or you can put a standard, but why put a standard when you can put a big one in it? So that's the kit. What else do you get? You get your gasket set, which is nice and handy, and I'd hope so. At the time of purchasing this, early 2023, that was £475 for a top end, which is a lot of money considering it's probably only going to make 6 or 7 horsepower. But nonetheless, it's cool, they're nice parts, and it will be a nice OEM Plus build. There's nothing else to do but get this thing together now. So we start with the piston, and I very carefully get this together. The last thing I want to do is snap a piston ring or damage it in any way. So you can see I'm really fettling them round, and following that I drop in the circlip for the gudgeon pin and make sure that the grooves aren't aligned. I know once it's in, but it's good to make sure it's definitely home. And then for the first time I get the piston onto the crank, and it is great to see. It's just funny to seeing such a bigger piston in this area. It's a big upgrade, so fits nicely, but yeah, you can definitely see where the gains will be made. And to be honest, aside from the larger volume, the process of building it is very much the same. We're going to oil the barrel and slide that over. These normally go together pretty well, and there's not much drama, so it is very similar to OEM. Main thing is just to take your time, check that you're happy with everything. Don't rush it, because with these aftermarket parts, the last thing you want to do is break it and spend a load more money getting another one. So pistons set in the bottom of the barrel, and we can pull that cam chain up into place and send it home. Obviously make sure your seals are in and your base gasket. Very satisfyingly it pushes home, as you can see, and the oil pushes out the top. We give that a quick wipe down and then move onwards to get the rest of it together. I've cleaned up these dowels and got them set in place, and moved to this side of the engine where we're going to drop in the cam roller chain. The torque wrench comes back out to tighten this up to the correct spec, and then we move up to get the head gasket in place. Now, compared to the original one, this is a steel press gasket. I think your original one is a standard thick gasket material, so it's a lot more heavy duty and a lot nicer to go with this kit. Now for my favourite bit, we're going to swap all the parts over from my old head to the new one. It comes pre-installed with valves, and all we're going to do is drop the cam in. I found out that I put this in the wrong way, so I quickly fixed that, and it comes in from this side, but the rockers go in and the whole thing gets assembled and adjusted as required. There is no real huge skill in assembling these, just take your time and, like with anything, make sure it goes together nicely. But you can see here we use the end of a bolt to push the rocker shafts in place. So after successfully getting most of the top end kit together, so we've still got to put the cap on for the top and torque it all down, but the piston and barrel are in the engine, which is nice. So the next Kitaco box we're going to move to is the manual clutch kit. So this is a full conversion. The bike comes standard with a 3-speed semi-auto. It will still be 3-speed, but now we're going to manual. Nice change, nice upgrade. I quite like the idea of it being manual on the road. A good bit of fun. So there's a nice kit here, so let's go through, unpack this, see what's inside and attempt to get it fitted. It is unboxing time for the manual kit, so let's have a look at what you get inside this set. First up is some bolts for your outer case, and then you've got your primary drive gear, which is lightened, it's thinner than the standard. Alongside that you've got the actual clutch pack, very similar to the standard one, and then here is the big part, which is your outer casing. Very nice quality, and obviously has the clutch lever, which is essential for this kit to work. Now, as mentioned, I did already put that old gear selector in, so I've pulled it out and dropped the new one in, which looks lovely and is nice and gold zinc plated. After switching those out, it is standard assembly. The lever hooks onto the shift pins, and then there's your star component which sits on top, and following that you can get your primary drive gear on. And once again, going to drop on a new circlip as that's quite a high load area. Moving to the crank side, we've got this bushing, oil light bushing that goes on, and then your main crank gear goes on top of that. And the most important thing here is that the clutch locates onto that gear in the back of it, so as that sprocket moves, or as that gear moves, so does the clutch. They act as one at this point and connect the drive of the gearbox, or from the crank to the gearbox and on out to the sprocket. It is all very similar to the standard setup. You have got your locking star washer that needs to be torqued. I go for the technique of jamming something between the two gears and then using the torque wrench to tighten it up. And as seen here, flip a little tab into place, and that makes sure that the clutch can never back off. At this point though, yeah, we are following standard process and the clutch is together. A very small piece, but not to be overlooked, a new oil filter goes in just to catch any crap that will come out of this engine. Despite being very clean, there's always some small residue that we will catch in this filter, so always worth to put a new one in, or at least make sure your old one is very clean. With that on, we can then go ahead and push this side casing on. Now I've opted not to use the supplied bolts, purely because they do not match the look I'm going for. They are Allen key socket bolts, and I've got these button JIS screws, which are more in keeping with the original look, so that's what I've opted for. And yeah, aside from that clutch lever and maybe some small different changes, it is pretty identical to what you would get on a CT70 H model, for example. With these last two screws, that is essentially the clutch side buttoned up for now. That won't be touched until we go to fit a clutch cable, which will be in the running bike. And to finish up the top end, in goes our cam sprocket. Obviously you have the timing process to make sure that the circle on the sprocket aligns with the cylinder head marking, but that is nothing too difficult and something I've covered before. And pretty much we're just finishing off the last little bits now. So exhaust studs are going in. These are the standard ones that come supplied with the cylinder head, so we get them screwed in and then hop up top where we're going to fit our carburetor. Now with a bigger piston and more power, you need to provide fuel for that to run, so we are going to be upgrading the carburetor to a PC20 carburetor. Alongside that we got a rotating carb stack and a new inlet, and this all just allows more air and fuel to flow into the engine. So we get it tightened up and it looks really good. It is way bigger than the standard, so to support that we've also got a nice air filter, because with this bigger carb and this bigger setup, the original parts do not fit, but it's a cool upgrade and I think this will look really good. As we stand, this is what our engine looks like, and I have to say it's come out brilliantly. I'm over the moon with the look of this engine. It is so clean and fresh. Granted, there are a lot of new parts, but nonetheless it is an old system that has been upgraded. I'm very happy with it, and it's a great base for this restoration. I'm trying to make this a top restoration, or resto mod I suppose, so having the engine sorted to this high standard is a great starting point. And potentially covered in the title, I want to try and get this engine running before it's in the bike, and that should hopefully be included in this video. So to do that, you definitely need a flywheel, as that is allowing the whole ignition system to work. So I run a tap or die across those threads, and then I get the impacts out and just tighten down that flywheel so it's all solid. And its final tweaks at this point, we're just going to talk over these cam sprocket bolts and then start to fit the final parts. These include our top engine cover, valve tappets and the side case. So gasket goes on, new top cover and some fresh nuts to torque down that whole setup. And as you can see, torque wrench comes back out to make sure these are all torqued appropriately. This build was spread across a few weeks, mainly because you normally think you've got all the parts and then you go to build it and realise that you're missing this or missing that. The valve covers were one of those things. I thought I had them, but then realised they were in awful condition and I thought, let's just get a new set. We've gone this far with everything else, it's a shame not to make it perfect. Same goes with a few other bits, so yeah, filming was slightly broken. So we're moving over to my friend's workshop to hopefully get this thing running as a test. Now, if you watched my last video, great. If you haven't, go and watch it because I show this engine stand, how it was built, and all the cool things behind it. But pretty much it's a bespoke engine stand designed to test these engines. My friend Cliff here specialises in all Honda stuff and particularly the bunky bikes. So he's testing engines constantly, so this thing speeds up the whole process for him. Now, before we watch this full engine starting saga, I have to say it did not run, and after we've gone through this little clip here, I'm going to talk to you why and say. So we get the engine primed, we put a new spark plug in it, we go through all the process of getting it hooked up, we've got a nice carb bolted to the top, all of the electronics are going to get plugged together, and in theory it should be exactly as if it was in the bike. For those that watched the first video, we never got this engine running, and I didn't really know why, because we had spark, we had fuel, we had air, and in my opinion we had enough compression, but still it did not run. And through building this engine I kind of revealed the real reason why. So you'll see here we get everything hooked up and we'll go to turn this engine over. We're turning it over on the crank, which isn't the best thing to do, but it's the easiest way to turn an engine over quick, missing out the Kickstarter. So we add it on and you'll see the engine turns over, it sounds good, but it doesn't actually fire. We've got strong spark, we've got oil pressure, we know we've got loads of compression, but it doesn't do anything. So the next big issue is we've got so much compression we can't turn it over. So you can see here when it does turn it's good, but nothing, literally nothing, and we were baffled. So let's go into why this thing didn't run. Right guys, you've just seen us trying to start the engine and having no luck, and I think I need to go through the explanation of why this doesn't work or why it didn't run. So for those that have watched the first video, we never got this engine running, and we put it down to lack of compression, but we had spark, we had things, and it should have ran, but we were always baffled to why. Through this process and it not running, I went through and eliminated what it could be. We've got piston, we've got all these new parts, so it should run. The one thing that was standing out to me was the electronic ignition system. So it's a new system and you automatically assume that should work perfectly. And to be fair, the unit did work perfectly. What wasn't working or wasn't being up to standards was the flywheel, which is the last thing you would think not to be perfect. So the flywheel has magnets inside it, and what I found out is that to run a standard point and condenser ignition system, you don't need a lot of voltage draw from the unit. As soon as you move to electronic ignition, it requires the full output from the system. So after sitting for 55 years, that flywheel is definitely demagnetised and lost the ability to produce the voltage it once could. Hence the reason we never got this running on the electronic ignition. I didn't have the condensers at the start because the unit had been taken off, so this was my only option. What I can say is we fitted points and condensers to this and the engine ran mechanically sound. It was spot on. When we put a new flywheel on, when I say new, we nicked it off of the Z50 down there and we switched them over. We had the issue where, because we've got so much compression, we weren't able to turn the engine over on that nut. It kept backing it off, so it was a bit of a saga. I know the engine is mechanically sound, and I've had this electronic ignition and the other flywheel on another engine and proved that it works. So we haven't 100% proved that the engine runs, but I know that it's sound, which is good enough for me moving forward. But hopefully that clears it up and puts a bit of clarity to why we didn't run in the first video, but that's part of it, figuring out these problems and finding a solution. But that's going to be it for today's video. I really hope you've enjoyed watching. A lot of time and effort goes into making these. I know they don't come out very quickly, but I just don't have the time to devote at the moment to just making videos. But if you did enjoy it, please do like the video and subscribe if you want to see more. We have got an abundance of parts on the shelf, and I'm hoping that in the near future we'll be finishing this project off and you'll see it going down the road. But until then, take it easy, look after yourself, and I'll catch you in the next one.